मेरे पास ज़्यादा ये क्वेश्चन है ना पूरा डांस प्रैक्टिस कर रहा
Good evening. Where is that boy who fell down? How are you? Okay? You didn't break it, no? Just got sprained a little bit.
Yes, and there might be a crack.
Which will heal. Which will heal well. Sure. Be careful, huh? Where were we in the last class? Did we finish the chapter? I know I went a little fast. If anybody has any doubts, any clarity needed, you attended last class, right? And there were many, I think, boys were in less number in the last class. So, did you go through the video lecture?
Yes.
The rule is when you are absent, you have to go through the video lecture before attending the next one. Otherwise, you will face continuity issue, right? So we finished optics completely, I think. Please tell me if there is any topic yet to be done. Are we done with sign conventions? Power, then estimation of focal length experimentally. Did we do lens formula? Okay. Did we do sign convention? No, last class were you present? Then did we do these experiments? Estimation of focal length? Okay. So I think sign conventions and length formula only that is remaining, right?
Yes.
So some more formulas. So pay attention. So this is our principal axis. Okay. So principal axis is like our x-axis in mathematics. Cartesian. So it is same as Cartesian sign convention. Just check this spelling if I have written it right. Cartesian sign convention. Okay, so x-axis, y-axis. So the lens is placed here. The y-axis is the aperture of the lens. What is aperture? The diameter of the lens. Okay, this is the y-axis. And what is the intersection? It is the optical center. So origin of x and y axis is the optical center of the lens. Is it clear? So this is like x-axis. So now what is positive? Okay. So all the incident rays will come left to right. Okay. Incident rays will always be left to right. And all the distances will be measured from optical center. Are you listening? All the distances will be measured from optical center. So if the object is over here, what is the object distance? This is the object distance. So this distance will be positive or negative? This is negative x-axis, right? Origin to left is negative. So this is negative. Any distance measured to the right will be positive. Okay? Now, any distance measured upward should be positive. So upward of principal axis or x-axis, positive. Both sides. Right? So this is positive. Any distance measured downward is negative. Okay? This is the sign convention. So where is our lens? This is our lens. It could be convex or it could be concave. Okay? So now tell me. So now if this is the rule for sign convention, then what will be object distance? U is always object distance. What is U? Object distance. What is the symbol for object distance? Object is always kept in front of the lens. Right? So what will be sign of U? Negative. Always negative. Okay? So this is the first. Second. What about image distance? So what is the image distance symbol? V. So it is what? Real images will form after the reflected rays meet somewhere. So reflected ray will be, it will behind the lens because it will, refracted. So refracted rays will pass the lens and they will meet behind. Real image is always found behind the lens. Correct? So V is positive for real image. Isn't it? And virtual image will be in front of the lens. You know this. Do you all know this? Where is the virtual image found? always on the left side, in front of the lens, right? Whether it is convex lens or concave, virtual is always in front of the lens. So V is negative for virtual image. This is also a test for you if you are getting otherwise the answer, then your answer is wrong. Okay, whenever you are calculating the image position, if you are saying that image is real and your V is coming negative, that is wrong. Okay. So you got U and V. Now what is the sign convention for focal length? F. So for convex lens, it is always positive. Positive convex lens. Focal length is positive for convex lens. Okay, focal length is focal length. Okay, focal length. So focal length we already given. What is the symbol of focal length? F, small f. And f is negative for very important for solving numericals. For concave lens. Now in numerical, they don't mention the sign. They just say it is a concave lens, convex lens. Then it should flash in your mind and you should write the data with the appropriate sign. Which sign you will not write? The one you have to calculate. Calculated sign you don't have to assume. Okay? Like in the formula. Now what is the lens formula now? So lens formula. You have to only remember the formula. Derivation is not there. Okay? What is the lens formula? 1 upon f is equal to 1 upon v minus 1 upon u. This is the lens formula. So in the numerical, whichever data is supplied, okay, you will write that data with the appropriate sign. And the unknown sign will be obtained after calculation. This is the process, right? So note. Right? Or substitute the given data with appropriate sign. Signs as per sign convention. So we have discussed all the sign convention. Only two sign conventions are left for magnification and power. Right? So what is the magnification for real? What is the symbol for magnification? Small m. What is the magnification formula? Magnification of lens. M is equal to given by V by U. Okay. Image size upon object size. This is equal to V upon U. Okay, what is I? Image size upon object size. So what is image and object? Object size is vertical, this. So object size is always positive. Image will be negative for real and it will be upright for virtual. Okay? If it is behind the lens, it will be real image. Front of the lens, it will be virtual. So for virtual, M should be positive because both V and U are negative. Okay? Now for real, object size is positive but image is negative. So magnification for real image will be negative. Understood? So M is positive for virtual image. M is negative for real image. So whenever in numerical it is just given magnification is 3 and the lens is given concave. पॉसिबल है क्या मैग्निफिकेशन कॉनकेव में 3 हो सकता है नहीं होगा कॉन्वेक्स ही रहना पड़ेगा बिकॉज कॉनकेव में क्या होगा इट इज ऑलवेज डिमिनिश्ड ठीक है सो बट इन कॉन्वेक्स लेंस यू हैव ऑल टाइप्स ऑफ इमेजेस इक्वल साइज बिगर स्मॉल रियल एंड वर्चुअल मोस्ट क्रूशियल इज फॉर कॉन्वेक्स लेंस ओके then what remains is power. So power will be sign will be derived from the focal length, right? So only 2 things remaining here. Likewise, B. Power is positive for convex lens, negative for concave lens. So I am writing focal length and power. So with this, we have taken care of all the signs in it. So with this, we have come to an end of this chapter. For both this lens formula and magnification, only formula you have to learn. Derivation is not in scope, although it is given in your book. So, if you are done writing, come on page 93 of volume. We'll discuss some questions. Okay, so these are application type questions. 93. Some of those writing. Is everybody done right? Okay, so start with the first question. We start from you. Classwork question number 1, page 93. Application type. Read.
A ray of light incident at a point on the principal axis of a convex lens passes centimeters through the lens. One special mode is given to this point on the principal axis. The neighbor diagram is shown.
What is the name of the point?
Optical center.
Optical center, right? Everybody knows this. So does anyone need explanation for this? Okay. Second question then.
State the conditions for each of the following. A lens that has both its focal lengths equal. B, a ray passes undeviated through the lens.
When will you have the focal length equal on both sides? Both curvature should be same, isn't it? So if you have a convex lens like this, it will have both the focal length at same distance, isn't it? But if you had a lens like this, then this will have a focal length here, but it will have an infinite focal length because it is a plane surface. So the answer is, state the condition for each of the following. Lens has both its focal length equal when the both side curvatures are same. When a ray passes undeviated through the lens when the ray is along the optical center. So principal axis also passes through optical center. So optical center, the ray could be either along the principal axis or anywhere. It should be along the optical center. Understood, everybody? So part B of question 2 is same as question 1. Yes. Good.
The diagram below shows a lens as a combination of a glass block and two prisms. First, name the lens formed by the combination.
What lens is this?
Concave.
Concave lens. Okay. What is the line X dash called?
Principal axis.
Correct. Complete the path of the incident ray AB after passing through the lens. Divert. It will go away from the principal axis. Right? Everybody knows this because it is a prism. So the ray will bend towards the base of the prism. Right? Okay. Now, 4.
The final emergent ray either meets x dot x complement at the point or appears to come from a point on x or x complement. Label it as F. What is this point?
Where will be the F? So you have this is the diverging lens. This is called x dash, which is your principal axis. So the ray is incident along this, right? So it will travel till here, according. Now it will bend towards the base, so it will be like this. So we'll meet here. This point is F. So this is called focus. Okay, this is the focus. So which focus it will be? First or second? Is it first focus? Second focus. Yes. So ठीक है, it's all right. मतलब एक दो बार practice कर लेना. It is the second focus. right? And whenever the rays are parallel, incident parallelly, right? Wherever it, in case of convex, wherever it converges, then it will be F2 for convex. Parallel incident ray, wherever it converges, is the second focus. Okay? And where is the first focus? When the emergent rays are parallel, right?
Yes.
Then it is the first focus. So it's opposite. Incident ray parallel, wherever it converge or diverge from, is the second focus. Okay, this is how you remember it. Like in convex lens, when the rays will be parallel. So this is the first focus then. Okay. In the divergent case, when will it be parallel? When it is incident along focus. Like this. Isn't it? When it is incident along. Okay. So this is the first focus. When the emergent rays are parallel, that's when it is virtual focus. So this is first focus in that case. Got it? So this is always second focus. ठीक है, चलो. Have I mixed it up?
No.
Understood, na? Because now is when you discuss, you'll understand. Because now you are ready, right? Okay. Third of your four.
In figure F1 and F2 are the two foci of a thin convex
Foci
lens.
चलेगा यार, वो it's okay. Whatever.
Foci of a thin convex lens, and A is the incident ray. Complete the diagram to show the path of the ray A after refraction through the lens.
So after refraction, the ray A will pass through
Convergent.
F2.
F2. Yes. Okay. Okay. Everybody understood? This will pass through F2 like this. That was easy. Question 5. So in some questions, they will only give you a straight line, okay? They will not show you the lens. But then they have shown you the refracted. Then you have to guess what type of lens is it. Converging or diverging. Okay? Who's turn? Next. Okay, chalo. That's it.
Study the diagram below. Name the lens LL. Concave.
Concave. Okay? Or diverging. Both names are concave or diverging.
What are the points O dash called? Focus.
O dash are focus, yes. But the diagram is not shown correct. O dash should have been at equal distance like O. So
Complete the diagram.
this diagram is not correct. Huh? So misprint here. O dash should have been at equal distance as O. Okay.
Complete the diagram to form the image of the object AD. State three characteristics of the image.
Hello. So complete the diagram. So one ray is shown to you. So where will be the image formed?
Real and inverted on focus.
Real and inverted. Which lens is this?
Concave.
So concave में real बनता है क्या?
No.
हाँ, यही तो समझ ला है.
Virtual.
It will always be virtual and diminished. So it will be front of the lens. So you have understood ना?
Yes.
हाँ, यही समझना है. So you have, this is the object, and this is already given to you here. So the other ray you have to pass through optical center, isn't it? So where is the meeting point here? So AB will be A dash B dash. So you have to show this. Right? This will be the image form, virtual and वर्चुअल कभी भी हमेशा क्या होता है, डिमिनिश्ड होगा in case of diverging lens. In which lens the virtual image is magnified?
Convex.
Convex lens. What is the object position? Object position behind the mirror. कभी होता है क्या?
Between optical.
Object is always in front of the mirror. कहाँ से lens discuss कर रहे हैं? देखो ये होता है, ये होता है. तो take a deep breath and remain in lens portion. ठीक है? वैसा है. हाँ, अभी बताओ. When is the virtual image bigger than the object size? For what position? Between F and O. F and O in the front of, between F and O in front of the lens. ठीक है? That time the virtual image will be behind the object on the same side. Okay. State 3 characteristics of the image. Yes. Hang on.
State 3 characteristics of the image.
What is the image? Diminished, virtual, upright. ठीक है? Okay. तो सबको समझ आ रहा है ना? देखो क्वेश्चन ऐसे आता है. Yes, your turn. Question 6.
Complete the diagram shown in the figure below to show the formation of image A, B of the object AB.
A dash B dash है, वो misprint है. A dash B dash
A dash B dash
of the object A.
of the same size. Name the length L dash, LN dash and draw its outline. What are the points O1, O dash, and where is the object located? Where is the image formed? What are the two characteristics of the image?
Convex lens.
Let जिसका turn है वो answer करे. Don't speak out of turn. हाँ. And everybody else do for yourself. ठीक है? Then we discuss for the whole class. So what type of lens will make our image at the same position as object and at the same size, of the same size? Convex. So where do you expect the object position? At center of curvature, right? Twice the focal length. So when the object is at the center of curvature, that is when. So when object is at C, image is also at C on the other side. 2F on the left, 2F on the right. Isn't it? Have we not discussed this? हाँ? अरे बाबा तो वीडियो लेक्चर नहीं देखा क्या बाद में? चलो ठीक है. So I am telling you, there are only 6 object positions. Infinity, beyond C, which is 2F, at 2F, between 2F and F, at F, between F and O. So there is a table given in your book. ठीक है? And it's very simple, logical. Just go through the video lecture. If you don't understand, ask me in some doubt clearing session. ठीक है? So what is the answer? Object has to be at 2F in front of the lens. Then the image will be formed at 2F behind the lens. And the size of object and size of image will be same. So what are the points O and O dash called?
2F in front of OCD. 2F.
2F नहीं है. O is not 2F. F है. O is between. ये डायग्राम ना थोड़ा सा सिमेट्रिक नहीं दिया हुआ है. That's why. O is half the distance. Okay, O is half the distance of object in this case. So it is F. So O is F2. O dash is, sorry, O is F1. O dash is F2.
Convex lens.
Convex lens. So on the right is F2, on the left is F1. Now where is the image formed? 2F2 behind the lens. What are the two other characteristics of the image? Real and inverted. Same size दिया हुआ है. Size, nature and orientation. These are the three characteristics of any image. Size is given equal in the question itself. Then it is real and inverted. Okay. किसी को कुछ भी question है?
Sir, O is F1.
O is F1. Convex में right side में wherever the parallel rays converge. Okay, incident parallel rays wherever it converges or appears to diverge from, that is F1. That is F2. Incident parallel rays wherever it converge. So it will be on the right side in case of. So O dash is F2. Okay, your turn.
The diagram given below the figure shows the position of the image OA in relation to two converging lens whose
So what I will do is I will straight away move to question 11. So very similar questions we have done so far. Okay, so now there are some numericals also. I don't want to miss out. So chalo 11 क्या है?
where must an object be placed in front of convex lens so that the image formed may be at infinity.
So where the object is kept for the image at infinity? At focus.
Yes, sir.
When the object is at F, image is at infinity. Right? Now, same size as object. It is same as question 6. 2F. Okay? Inverted and enlarged. When is object inverted and enlarged?
When it is a real image.
Between 2F and F. Between 2F and F. Same size 2F तक होता है. 2F से आगे गया तो image will be enlarged. Till F. F पे it will be highly enlarged. Highly magnified. Because the image is at infinity. And between F and O it will be enlarged but it will be virtual, not real. So it says inverted. So inverted means it is real. Okay? So all these concepts should be very, very clear now. Okay? All right. Is it understood? Okay. Question number 12. Whose turn? Your turn, I think. Is it your turn? Question 12. Sure. Let's do this numerical. So in numerical, we have to write the given data first. So what are the given data? Tell me. So candle of length is object size. So given. So this is question number 12. So given O is equal to 3 centimeter. This is plus, right? What else is given? So placed in front of convex lens so that its image is of length. So I is equal to. So image is magnified, right? Right. And it is double the size, correct? So what it should be? On a screen place that it is behind the lens, it has to be real, right? So real means it should be minus 6 centimeter. Understood? This is how you have to figure out. Behind the lens, image is forming. It is bigger. So it could make a bigger image in front of the lens also. But what is given? It is obtained on a screen placed at a distance 30 centimeter behind the lens. Therefore, V is equal to plus 30 centimeter. Is it clear? If it is behind the lens, that means image has to be inverted. So it should be minus 6 below the principal axis. Is it clear? This is what I was saying. You have to pick the right sign. Okay? So images of real nature. Okay. Then what you have to find out?
Position of candle.
So you have to find U. Okay? missed it. What else you have to find? You have to find anything else? What is the focal length of the lens in part A? These two things you have to find. Sure. कैसे करोगे? Solution. What is M? M is equal to I upon O, and this is equal to V upon U. Okay, so what is I? That is minus 6 upon 3. V is 30. Then here U. Okay, and U should be negative, I told you. So now cross multiply. U is equal to, so take the minus sign here, 30 into 3 divided by 6. 15. So U is equal to minus 15 centimeter. Okay, so in the answer you are getting U negative, so it should be correct. Okay. Now for, so we got the position, we got this. Now use lens formula. So using lens formula, what is 1 by F? V is 30 minus 1 by minus 15. So this is 1 by 30 plus 1 by 15. So take the LCM 30, 2, no, this is 1 plus 2, right? So this is 3 by 30, 1 by 10. So 1 upon F is equal to, this means F is equal to 10 centimeter. You have to also write the name of the lens. If the numerical value, is it given convex?
Yes.
So also write the name of the lens. So focus should be positive for convex, and that's what we have. Okay, so these are the checks. Once you know the sign convention, this is how you verify. So we got F is equal to plus 10, which looks correct. Okay.
So the minus 15.
So minus is what? U, no? You got U minus 15.
But then minus how we won't take it.
Minus minus.
Yeah.
Happens. So good question, right? Next. So everything got used in this. Magnification, sign convention, lens formula, except power. Power के लिए अलग से question आएगा, ठीक है? Okay, 14. So this is part B, and this was part B, and this was part A. Okay, question 13. Your turn.
Focal length of a convex lens is 25 centimeters. At what distance from the optical center of the lens an object is placed to obtain a virtual image of twice the size?
So given convex lens, the F is given how much?
25 centimeters.
So it has to be plus 25, right? Because it is convex lens. At what distance from the optical center of the lens an object? So U is equal to what? What is V? So virtual image of twice the size. So virtual image of twice the size. So when it says virtual image in convex lens, virtual image will form in front of the lens, right? So what is M? So given V is 2 times U. Okay, and M is plus 2. Right? Okay. Basically, when what is given is M given. What you have to find out? That is particular what? Okay, so now, therefore, since M is equal to solution, okay? Since plus Q minus since virtual length. It is also magnified. So M is equal to V upon U. Now M is 2, right? So 2 is equal to V upon U. So this gives us V is equal to 2U. Okay? So now what is F? So this is equation 1. Now by length formula, one by F is equal to 1 by U plus, oh sorry, 1 by V minus 1 by U. Minus 1 by U. Okay? So what do we know? We know V is 2U. So this is equal to 1 by minus 1 by U. And what is that? 1 by 25. So what is it now? So 2. So this will be minus 1 by 2. 1 by 25 is equal to minus 1 by 2. Right? Correct now? So half minus 1 is what? People looking blank. Half minus 1 is minus half, right? So this is equal to minus half. So minus 2. Okay? This means what is 2U? Yeah. So U is equal to minus 12.5. So this is the answer. Minus 12.5 centimeter, which should be correct.
Yeah.
Okay? Because why it is correct? For what object position we get virtual image in case of convex lens? F and O. What is F? 25. Where is the object? 12.5. So it is between F and O. Okay? So this is how we will cross verify. You have time till? Lot of time. So next numerical question. Okay.
An illuminated object lies at a distance 1.0 meters from a screen. A convex lens is used to form the image of object on the screen placed at distance 75 centimeters from the lens. Find first the focal length of the lens and second the magnification.
Okay. So write down the given data. Question 14. Given. So name of the lens. Convex. So this will help you figure out the sign of the focal length. So U is equal to how much? Tell me. Object lies at 1 meter from a screen.
1 minus
So, an illuminated object lies at a distance of 1 meter from a screen. A convex lens is to form the image of the. But where is it kept? Convex lens is used to form the image of the object on a screen placed at a distance of 75 centimeters from the lens. Okay, so if it is 75 centimeters from the lens, then it has to be behind the lens only. Because if it was on the same side of the lens, and if it is, then it should be more than 1 meter, right? So this is something like this. Let's say this is the object, and this is the screen, right? So this distance is 1 meter. Okay, and this distance is 75 centimeters. Got it? So where is the object kept? 25 centimeters. Alright? This is the screen here. Read the question again. This is the situation. So therefore, what is U? U should be minus 25 centimeters. V should be plus 75 centimeters. So what we have to obtain now? Find the focal length and the magnification. Okay? What is the focal length? Focal length will be 1 by V minus 1 by U. So this will be 1 by 25. 1 by, what is U? Minus 25. Right? So 1 by F is equal to 1 by 75 plus 1 by 25. LCM 75, 3. So 1 by F is equal to this. This is 75 by 4. How much is this? 4 ones are 4, 35. 4 eights are 32. 3. 4 sevens are 28. 4 fives are 20. Right? So 18.75 centimeters. This is the focal length. Is it correct? Are the answers given here? I think this is a textbook question. This should be a textbook question. Let me check. Yes, 18.75 centimeters. This is a textbook question. Question number 5 from exercise 5C. Okay, so it was a slightly tricky question, but we got it. Right? So find the magnification. That's part 2. This is correct. So you have to read the way question is asked. So magnification should be easy. What is the formula for magnification? M is equal to V by U. So V is 75. U is minus 25. So then minus 3. So magnification is minus 3. Negative means real and inverted. तो ये हमको पहले ही समझ आना चाहिए था कि रियल एंड इन्वर्टेड है तो स्क्रीन शुड बी बिहाइंड द लेंस. From here we could have found magnification first. It is our second, but from the given data, magnification tells us it is real and inverted. So screen will be behind the lens. Okay. So therefore the distance between screen and object is 1 meter. Read the question. So screen is behind the lens and therefore the image is behind the lens. Yeah.
Next comes the image of an object placed at a distance of 45 cm from it on a screen base at a distance 90 cm on the side of it. Name the kind of lens, convex.
Convex, yes.
We find the focal length of lens and magnification of the
So it is similar to previous question. Okay, go to the next question. Power. Question 16. 15, everybody, you can do it yourself. Similar to question 14. Okay, convex lens का question है. Question 15 read करो.
15.
Sorry, 16.
The power of the lens is plus 2.0D. Its focal
No,
length.
it is her turn only. Where she got a pass, na? Why are you with this? You have to read. No, you have to read. अभी आएगा तुम्हारा turn बाद में. Question 16.
The power of the lens is plus 2.0D. Find its focal length and scale the line of lens.
So power positive है तो focal length क्या होगा? Positive. तो lens क्या होगा? हाँ? Okay. So P is equal to 1 by F. Right? Therefore F is equal to 1 by P. So 1 by plus 2. This is 0.5 meter. Power के फॉर्मूले में फोकल लेंथ हमेशा मीटर में होता है. So this will be 50 centimeter. चलो 16 हो गया. So what? So we got the focal length. State the kind of lens. Focal length positive, so it should be convex lens. Why convex lens? Since positive focus. Okay. Chalo bhai, last question.
The focal length of a convex lens is 25 centimeter. Express its power with sign.
So given F is equal to how much? 25 minus तो नहीं है, plus 25 centimeter. तो ये कितना हो गया? Plus 0.25 meter. Okay. So what is power? 1 by 0.25 diameter. This is 100 upon 20. Plus 4 diameter. This is one. So with this, we are through with optics. So in the next class, I'll be starting with spectrum. Is it taught in your school, spectrum?
No.
Which chapter is going on? Lens. Lens means this one, the one we just finished.
First, we have to start with the light chapter.
Okay, for you.
First.
Achha. So means we are going ahead. No?
Yes.
with any school are we behind? नहीं ना ठीक है चलो तो you should be comfortable हाँ चलो see you in the next class.
Thank you, sir.
Forty or 20. What is it? 60.